Hi, I'm Smog. Smog, you've seen me in such fine quality. Epic movies such as Hobbitses Are Yummy and I Love My Gold. Okay, here we are. Chapter 18, Air Pollution. Let's do this. So we're going to look at the atmosphere. It's structured in layers, and it has the troposphere and the stratosphere. That's what we're going to be focusing on. So when we look at the atmosphere, it's made up of layers. A lot of it is nitrogen and oxygen, not all of it. Water vapor varies at the poles to the tropics. Less than 1% argon, and the biggest evil gas of them all, 0.038% of the atmosphere is actually made up of CO2 and trace amounts of other gases. Now, in the atmospheric pressure, it's the mass of air per unit area. So in other words, the higher you go up in the atmosphere, the less air pressure that you have. Duh. So that being said, okay, moving on. So the troposphere makes up most of the air mass. This is the part of the atmosphere that we exist in, involving chemical cycling, thin and turbulent air currents and winds, largely responsible for short-term weather and long-term climate. Okay, ozone formation, we talked about that, keeps out 95% of the UV radiation out there from reaching the surface. So, now we're looking at pollutants. This is going to be a biggie. We do have pollutants that mix in the air from industrial smog, mostly the result of burning coal, and photochemical smog caused by motor vehicle, industrial, and power plant emissions. Let's do this. So when we look at air pollution, we've got to look at presence of chemicals in the atmosphere, that they're high enough concentrations. It can affect humans, plants, and animals. Now the funny part about this is well, what are the sources of this air pollution you're talking about? Majority of it is from natural sources. Not humanity, mind you, natural sources. Keep that in mind. So dust particles, organic chemicals from decaying plants, forest fires, volcanic ashes, and sea spray. Yeah, so it's not really people causing that, it's natural nature. And I want to point out when they sit there and say, oh, we're burning all the fossil fuels. You have any idea how much volcanic ash, when the volcanoes erupt, how much they throw into the atmosphere? A whole lot more than, you know, the smoking car going down Euclid. I'm just saying. Okay, now humans do help in this process. We talk about burning wood and coal, gasoline and natural gases. Our sources, they're stationary, like power plants and factories, mobile and motor vehicles. Yes, I did put in AOC's picture because of the New Green Deal! Woo! Oh wait, that got turned down by the Senate. Okay. Primary pollutants directly emitted, given off directly to the troposphere in harmful form, like soot, CO, CO2, SO2, NO2, NO, and most hydrocarbons. Okay? We talked about carbon monoxide, CO, that's 2 carbons plus O2 gets us 2 CO. Sources, cigarettes and car exhaust are big ones for carbon monoxide. Nitrogen dioxide is another source. Fossil fuels and industrial plants. Now it can combine with hydrogen in the atmosphere to form nitric acid, HNO3, otherwise known as acid rain. Now we're going to talk about that a little bit later on. Tiny bit later. We also have sulfur dioxide. Now our chemical reaction is S plus O2 gets us SO2. The sources of sulfur dioxide is coal burning in power plants and industry. And this is the result of some sulfur dioxide poisoning when we have that in the pollution. Other primary pollutants, suspended particulate matter, SPM, burning coal and diesel, unpaved roads, architecture, and construction. That covers a lot of things, okay? We're going to do a lab and we're going to investigate particulates that we pick up. We have also ozone, which reacts with volatile organic compounds. Not fossil fuels! Volatile organic compounds and nitrogen oxides. Now, the good ozone in the stratosphere filters out ultraviolet radiation. The bad ozone is the pollution when it is in the troposphere. And if you're in Southern California, you actually experience that. Just saying. Now, that's a second copy of that slide. There we go. Then we have lead. Okay? Lead, paint, lead making, storage batteries, leaded gasoline. Although it's being phased out in developed countries, pretty much I would say it's gone now. You really can't go to a gas station and you'll notice they'll always say unleaded, unleaded, unleaded. Those days are gone now, having lead in gasoline. Again, lead in paint, they don't do that anymore. It was an issue about little kids peeling paint that had lead in it, eating lead chips, paint chips that had lead in it. That was an issue at the time, and that does cause things like decreased cognitive abilities, fatigue and headaches, irritability, constipation, and abdominal cramping. Not fun. So there's some serious issues with pollutants. All right, primary pollutants we talked about. Volatile organic compounds, VOC. Now, what does volatile mean? Some people would look at volatile, if somebody is angry, they get very angry very easily. We could say that that person is volatile. Really, when you're thinking about volatile in the sense of AP Environmental Science, you're looking at how easily it evaporates, how it goes from a liquid to a gas. It evaporates fairly easily. That's what we're talking about. Now, most of them are isoprenes, C3H8, terpenes, C10H15, and methane, CH4. Those are the VOCs, your volatile organic compounds, given off by leaves of plants, not fossil fuels. Okay? 33% of the methane is given off by plants, wetlands, and termites. Wait, termites? They're giving off methane? Right, they farted out. 67% are human sources, things like landfills, where we bury our garbage and the garbage breaks down, it decomposes underneath. Oil and natural gas wells and belching cows. Yes, belching cows. Can you imagine? Here you go. Here's an example of a landfill, and here's an example of a belching cow. Yeah. Exactly. So, but you say, well, what about those landfills? Well, remember, this stuff is also breaking down. And because it's breaking down, it will release chemicals into the atmosphere. So this is another cause of pollution, but it is a human cause. This is a natural cause for this. Okay? Now, what about secondary? Those are primary pollutants where we release it directly into the atmosphere. And now we got to look at secondary. Now, in this case, primary pollutants that react to form other pollutants, that's what we call secondary. So PANs are example, peroxyacyl nitrates, like NO3-, SO4- 2, salts, and ozone. Yes, I said salts. You know who you are. Okay? So again, these come from primary pollutants that they're able to combine again with other pollutants to form other types of pollutants out there. Okay? That's just the way that it is. Okay? Okay, how about smog? Not smog. Photochemical and industrial smog. Photochemical smog is brown air smog. It's activated by light. It's a mix of NOx and volatile organic hydrocarbon compounds with UV. Okay, now what is NOx? That means nitrogen and oxygen put together. The X can be a number, like NO, NO2, NO3. That's what they call the NOx. Okay, the volatile organic hydrocarbons come from natural and man-made sources. So we do get smog, photochemical smog. This is what a lot of people, when they say, oh my gosh, it's such a smoggy day today, they look at this brown stuff here, okay? Which, hey, this looks like LA. It is LA! And this is, mais bien sûr, ça c'est Paris, indeed, okay? Not even smog puts out that kind of pollution. But photochemical and industrial, now remember photochemical, there's two things there. Photo meaning light, chemical being chemical, so there had to be some light mixed in with the chemicals that were in the air to create that pollution, that kind of smog that we're seeing. Now, photochemical smog, how is it that trees can contribute to this? Well, they can. They give shade, which means there's less energy used for air conditioning. Trees also absorb carbon dioxide, they give off oxygen, they help absorb and remove various pollutants, that's true. Now the thing is, they also give off VOHCs. Those are the ingredients in photochemical smog. So that's just it. How are trees more beneficial or less beneficial in the big picture of doing the smog? Well, in all honesty, yeah, they do give off some stuff like VOHCs, VOCs, but what they're giving off compared to the benefits that we're getting from it, the good points outweigh the bad points. That's what I'm going to say. The good points of the trees outweigh the bad points. And it's true that trees give shade, less energy, and less energy that's used for the air conditioning. That's also very true, because if you have less trees, there's less shade, you need more air conditioning, you have more power, which means the power plants have to run and burn more fuel, which puts more pollution into the sky. See, cause and effect. Okay, how about industrial smog? Now this one is a mixture of sulfur dioxide, sulfuric acid drops, particles of coal and oil. Now this is where industrial smog is a bit different. You don't see it as much in Southern California. You see it more back east. Now gray air smog is the gray color smog formed by salts and carbon, which is in the form of soot. Soot is another way of saying ashes, little particulates, tiny particulates. Okay? Factors that influence the formation of photochemical and industrial smog. Rain and snow, they help cleanse the pollutants out of the air. Salt spray from the oceans, they wash out particulates and water-soluble pollutants. The winds sweep pollutants away, they dilute by mixing with clean, fresh air. That's why on some days, if the wind's been blowing, it is a beautiful day in Southern California, and it's so blue because the wind came by and blew all that air pollution out. Yeah, can you imagine that? Factors that increase pollution, urban buildings, they slow the wind speed, cuts down on dilution and removal of pollutants. You also have hills and mountains. They cut down airflow in the valleys, allows pollutant levels to rise. That's the other thing. High temperatures promote chemical reactions leading to photochemical pollution. So those are other factors that come in. Urban buildings, hills and mountains, high temperatures, all those things come into play, along with rain and snow, salted and spray from the oceans, winds, all those, they help either increase or decrease the amount of pollution that we have. Now, we also have something called the Grasshopper Effect, of which I've got to take a look at my timing. Okay, we're doing great. The Grasshopper Effect is the transfer of air pollutants from the tropics and the temperate areas to the poles. Okay? There is no place on the planet that is completely free of air pollution. That's the reality of it, folks. Sorry, but that's the way it is. Now, we got to talk about another thing called temperature inversion. So really what we got is the warm air layer on top of a cooler air layer. All right? The normal pattern here, you have a city, you have some warm air, you have cool air and cooler air. This is the normal thing that you would see if you were going up into the atmosphere. Temperature would go down. But in an inversion, we have cool air here, we got a warm layer trapped in between two layers of cool air. So what happens? I wrote down, who cares? Pollutants concentrate at the ground level. It never rises and it gets stuck there because that warm inversion layer is keeping it down. It's keeping those pollutants down in that area. Okay? So another thing to look at for temperature inversions is topography. There's two kinds of topography that go for it. One is a city that's in a valley that's surrounded by mountains. The mountains put a limit on things. And they experience cold and cloudy weather during part of the year. So again, we look at that normal pattern of warm air, cooler air. But when you have a thermal inversion, cool air, warm inversion layer, cool air, that gets to be a bit of a problem with that. So the city, now what about another scenario? The city, ocean on one side, mountains on the other, three sides. Sunny climate, millions of people, lots of cars, light winds. Ding, 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 not Jerry. Ding, 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 not Jerry. Ding, 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 not Jerry. It's LA. Los Angeles, temperature inversion is at least for half of the year for us in the summer and in the fall. This is what we experience. This is one of the places on the earth where we do know about temperature inversion layer. SoCal, you gotta love it. I love LA. Okay? Randy Newman came up with that song. Now this is overlooking from LA, downtown Los Angeles, from the Griffith Observatory. Okay? So I'm somewhere out there, I guess. But you can see this very distinctive layer of brown here. This brown stuff, those are the photochemical smog. That's the brown stuff. That's the stuff we see. That's not as bad as the stuff we don't see here. Okay, let me see if I got to continue here. I think we are going to stop here, ladies and gentlemen. So we did get to cover what was air pollution. We got to cover factors that help air pollution go down or increase the air pollution. Okay, and we also got to talk about the temperature inversion layer because, how does that happen? Why does it happen? And how is it LA is actually affected by that as well? Okay, this is Smog signing off.